Hi friends, welcome back in the series of neural network and deep learning. So today we will have another case study. So that is on autonomous vehicle, and we marked this as project 2. So before starting, I would again request you, please do like, share, and please subscribe the channel. Your one subscriber is very valuable for us. That will definitely motivate our team to keep working on it. So let's get start with this case study. So basically what the context is, so you can go through with the context. So basically recognizing multi-digit number in photographs captured at street level is an important component of modern day map making. A classic example of corpus of such street level photographs is Google Street View, Imaginary Composer, and all these things, right? So what we'll do is basically we are building a digit classifier on SBHN, that is Street View Housing Number data set, right? So here the required file will be providing we will be provide the link in the description. You can easily access it from there. Now before wasting our time, let's get started by importing necessary libraries. So again, warning used to suppress display of warnings. Now OS is used to provide a way of using operating system dependent functionality. We use it for setting a working folder or directory. Then Panda is of course used for data manipulation and analysis. Then NumPy is used for large multidimensional array and matrix, along with the mathematical operations on these arrays, right? Then Matplotlib is a data visualization library for 2D plot of arrays built on NumPy arrays and designed to work with the broader SciPy stack, right? So plotting using the matplot.pyplot, right? Then Seaborn is based on Matplotlib, which aids in drawing attractive and informative statistical graphics, right? So this is how we use Seaborn with the Matplotlib, and of course the TensorFlow is for our sequential or the model building. Now suppress display of warning, again the same thing, warning dot filter warning ignore, display all data frame columns. So we are using display max column none, so which will display all data frame columns. Now to set the limit to 3 decimal, so here we are using 0.7 to float dot format. Display all data frame rows, so option dot display dot max row equals to none. Now the first problem statement is read the .h5 file and assign to a variable. So basically we have got this file generated, and we'll be providing the same in the link below, so you can easily check it out from there, which is a shareable file, and you can download it and use it at your own. Now importing h5py, so open the file randomly. So h5f equals to h5py. If you do not have this library, please install it. Then to import this file, we call the file function, and in a read format, right? In a read access. Now print all the keys from the h5 file. So h5 dot keys, so you can see x test, y x train, x value, y test, y train, y value. C is that split the data into x train, y test. So of course we are using our own variable. X train will contain all this x train variable, y train will all the y train data, x test all the x test data, and y test is all the y test data respectively from the h5 file. Now a print shape of all the data split into xy train test to verify if x and y is in sync. So x train dot shape, so this is the shape we have, and x test dot shape, similarly y train and y test shape. Now visualize first 10 images in train data and print its corresponding label. So here you can see that we are making a function img label, and so that will take the number of images, plt dot figure, so defining the figure size, right? For I in range n, plot dot subplot 1 n I plus 1, then I am show, so we are showing x train dot the ith images, and where our cmap is gray, so it will show all the gray scaled. Now plt dot show print a label for each of the above images. So here you can see that we passed 10, we got these 10 images, label for each of the images these. So here you can see that in this image we have 2, in this we have 6, then 7, this is 4, this is, I'm also not able to see clearly, but yeah, this is again 4, this is 0, this is 3, this is for again 0, then 7, and then for 3. Now next is reshape all the image with appropriate shape, update the data in same variable, then normalize the image and normalize the pixel values. So xtrain equals to xtrain dot reshape, xtrain dot shape 0 1 0 2 4, and xtest equals to xtest dot reshape, xtest dot shape 1 0 2 4 1. Now normalize input from 0 to 255 to 0 to 1. So xtrain equals to xtrain by 255. Similarly for ytrain. So we have then the resized training set is this one, and resized test set is this one, right? Now transform label into format acceptable by neural network. Of course, print total number of classes in the data set. So tensorflow.keras.util import to categorical, then one hot encode output. So ytrain equals to categorical ytrain, ytest equals to categorical ytest. Number of classes, so number of classes equals to ytest dot shape. Printing the number of classes in this data set are a number of classes. So the number of classes in the data set are 10, right? Now design a neural network to train a classifier. So tensorflow.keras import optimizer, tensorflow.keras model import sequential, tensorflow.keras layer import dense flatten. So neural network model, so again model equals to sequential, model dot add flatten, model dot add dense. So all these input layer, hidden layer, and the output layer, and finally we are returning the model from here. So now if we call this function building the model, so again this will hold this model into this variable, then train the classifier using previously designed architecture. So this is what the architecture we have, and use best suitable parameters. So again compiling the model, so sgd equals to optimizer dot adam, learning rate is 1 e, and adam and learning rate, then model dot compile, loss categorical cross entropy, optimizer is sgd matrix accuracy. So here loss function equals to categorical cross entropy, right? This one. Now fitting the model, so training history equals model dot fit on xtrain ytrain validation data, xtest ytest, epoch is again 100, batch size is 300, and verbose is 2. So here it will go to 100 epoch, and the accuracy or the validation loss, you can see that 42%, right? So evaluate performance of the model with appropriate matrix. So final evaluation of the model scores equals to model dot evaluate x test y test, verbose equals to 0, then print loss. So score is 0, then accuracy score is 1. Now loss is 66% and accuracy is 81%. Now plot the training loss, validation loss versus number of epochs, and training accuracy, validation accuracy versus number of epoch, plot and write your observation on the same. So accuracy, training history dot history, validation accuracy, loss, validation loss, epoch. So all these things we are going to plot in our this line plot. So here you can see that training and validation accuracy. So but the training accuracy is the blue one, you can see, and the validation accuracy, right? And similarly the loss, the training loss and the validation loss. So there are some observations, like there are around 10 classes in the data set which represent digits from 0 to 9, that we have also seen, right? Now we tried training a neural network with a dense hidden layer of a different number of units, and are able to achieve the final test accuracy as 80%, that we have seen nearly here, right? This is the 80%. And also we noticed that after a certain point the model begin to overfit on our data, as is clear from the plot above, where the validation loss begin to increase. So here you can see that validation loss came down and then started to increase, right? And after a certain point, and validation accuracy begin decreasing. So this one, thus with this amount of accuracy we are able to distinguish between the different digit in the data set. So yeah friend, this was all about this case study. Hope you got some idea. Hope you were able to relate this case study with your own problem. If yes, if you like the content really, please do like, share and subscribe. That is very important for us, and we'll be back in the next video. Till then, all the best, have a good time.